everyone, looking at class number 32. Our goal is to break vectors into x and y components. Make sure your calculator is in degrees mode, not radians. So your house is at the origin. You want to walk. You end up 460 meters from your house at an angle of 50 degrees north of east. So this is north this way. This is east this way. So 50 degrees north of east. So you start at east and go north of it, 50 degrees. I'll draw it right here. There's your end. So here is your vector, like the way your displacement vector, 460 meters. This is 50 degrees. All right. Now, the next part is we have to figure out how far east did you walk, how far west did you walk, or excuse me, north did you walk. So you have to draw separate x and y components for this vector, representing how far east you went and how far north you went, how far in the x direction you went, how far in the y direction you went. Those vectors must be arrows. A lot of you just use triangles when you first did it, which is fine the first time you did it, but now those really have to be arrows. So this would be your x. This would be your y. Those vector arrows should guide you from start to finish. Notice the way they point. That's not optional. They can't just point any old way. Those vectors, the two components, have to be tip to tail. Tip to tail doesn't apply to the resultant, doesn't apply to the hypotenuse. It only applies to the two that you're adding together, the x and y components. All right, and these form a right angle there. All right, this is your y. So to get the eastward component, we have to think to ourselves, okay, eastward component, that's the x. So am I going to use sine, cosine, or tangent? You don't have to memorize SOHCAHTOA. It is on your reference table. You have to know where it is, though. So since x is the adjacent side, I'm going to use x, or I'm going to use cosine. So cosine theta equals adjacent over hypotenuse. Cosine of 50 degrees, make sure you're in degrees mode, equals adjacent, that's what I'm looking for, over hypotenuse of 460. I'm going to multiply both sides by 460. So 460 meters. I'll leave the units out for now. So 460 cosine of 50 equals adjacent. So I think this comes out to be 295 meters as my adjacent side. Okay, so this right here is 295 meters. So the opposite side, we actually could use tangent now, but let's not do that because in case we got the adjacent side wrong, let's just use what we have. So we're going to go y, we're going to use sine. So use sine equals opposite over hypotenuse, not adjacent, hypotenuse, sine of theta, theta being in this case 50 degrees, equals the opposite side, that's my unknown, over the hypotenuse 460, multiply both sides by 460, and I get 460 sine 50 equals the opposite side. So this comes out to be, I think, 352 meters is the opposite side. So this is 352. So those are your answers. You ended up 295 meters east of where you started and 352 meters north of where you started. Someone asked a good question, should those add up to 460? No. Using the Pythagorean theorem, though, it should work out. 295 squared plus 352 squared should equal 460 squared. So that's a good way to check your work. Now, there is an equation on your reference table in order to do these, okay? Most of you who are pretty solid with math kind of see what we did there, and you'd be pretty quick with doing this on your own. But if you're not solid with math, there is another way to do this. There is an equation on your reference table. The equations look like this. AX equals A cosine theta, AY equals A sine theta. So let's just talk a little bit about what those things stand for. So first, theta. You have to be careful. I don't really like using this equation because theta, a lot of students don't know what theta actually is here. Theta is the angle between the vector and the positive x axis. Sometimes we refer to that as the reference angle. Okay, it's the angle between the positive x-axis and the vector we're talking about. A, in both cases here, sorry to kind of cross the arrows. In both cases, what A represents is the magnitude of the, I'll say, original vector or resultant vector. All right, really important. So theta isn't necessarily the angle you're given. So you have to be careful of that. All right, so let's look at this next question here. An airplane takes off with a velocity of 210 meters per second at an angle of 16 degrees. What are the horizontal and vertical components of the plane's velocity? So you'll notice here, we can use, in this case, we can use AX equals a cosine theta because the angle we're given is with respect to the positive x-axis. And then we can use AY equals a sine theta because the angle we're given is with respect to the x-axis. Check those out in your calculator. Make sure you get those answers we have there. Again, those arrow directions are not optional. Drawing the arrows is not optional in this. Okay, they must guide you from where you started to where you ended. Okay. Now, this is a great example, this bottom left one, of a case where you are not given an angle with respect to the positive x-axis. So if you want to use AX or AY, you have to make sure you find this angle here, which is 55, just 90 minus 35. And you want to find the, let's see, the magnitude of the velocity eastward. Okay, so let's draw our picture. So we have the east component. Let's just draw the other component, the north component as well. Okay, so to get the east component, that's this side, the x component, so that'd be AX. So AX equals a cosine theta. So AX is going to be, let's see, this is 24, I think it says. Yeah, it's 24 up there. So 24 cosine of 55, which should give you 14 meters per second. All right, check out that math there. If you wanted to use that 35-degree angle, okay, notice that you would draw a triangle this way, going, ignore the color scheme, but up and over. You'd have to notice that that's the opposite side, so it'd be sine of 35. So 24 sine 35 would give you the same answer, because cosine and sine of complementary angles are congruent. The next one here, check out the work there, but you're given 45 as the force. The x component is 45 cosine 65. Why can you use 65 here? Because it is the angle with respect to the positive x-axis. Now, number 10 here, I will say, is a very challenging question. What I will do actually is let me erase this. I should have erased this before we started looking at it. But I'm going to erase this, and we'll talk about it bit by bit. I'm going to go through it quickly, but don't hesitate to look back through the video and see what may confuse you, and make sure you're able to do this one. This is a tough question, but it's there's a lot of good stuff in here. So we have 150 Newton force that is applied to a wooden crate at an angle of 30 degrees above the horizontal, and it causes the crate to move at constant velocity. So right there, that is a huge key word there, constant velocity. That tells you a few things. The acceleration in the x direction is 0. Therefore, the net force in the x direction is 0. Okay, so it's an equilibrium in the x direction. It is also in the y direction, but we don't really have to talk about the y direction here. It's also a wooden crate on a wooden floor, and it's moving. So the coefficient of kinetic friction is the one we're going to use, which is 0.3. That's from your reference table. Go check out where that is so you know where to find it. So the first thing is find the horizontal component of the 150 Newton force. So let's draw our triangle. We have this part here. That arrow goes up. We have this one here. This arrow points to the side. Right. So we're looking for the horizontal component. So that's AX. So this is simply 150 cosine of 30, which is going to be 130 newtons. So that's the answer to this one, 130 newtons. Just for fun, let's find the y component or the vertical component. This is 150 sine, because this is AY of 30. And we're able to use the 30 degrees because this is the angle with respect to the positive x-axis. This comes out to be 75 newtons. Now, find the magnitude of the frictional force acting on the crate. Let's just really quickly draw a free body diagram, because I think it's a great habit to get in for this question. There are some shortcuts for doing this one, but I think a free body diagram is really the best way to do it. Right, so we have our 150 Newton vector. Okay, that's a force acting on this crate. We have friction. Friction always opposes motion. Since it's moving to the right, friction will have to point to the left. Some people ask, well, why doesn't friction point down into the left? Well, friction opposes motion, not necessarily the applied force. So since it's moving to the right, friction points to the left. We have weight pulling it down, negative Fg. We have normal force still. That's still there. So F normal. All right. Now, these are the only 4 forces acting on it. Now, the next part, if you take AP Physics, they don't really want you to do, but I like to draw in the components of the 150 Newton force on the free body diagram, because even though those aren't technically forces, they are a mathematical tool we're going to use here. So Yes, they aren't forces that should be included on your free body diagram because they're included within this 150 Newton force, but for our purposes, I think it helps a lot to see them. So this one was 130 Newtons, and this one going up was 75 Newtons. Okay, so we got to find the frictional force. The frictional force is in the x direction. So here's what we're going to do. Now, we can only work in the x or the y direction at any given time. We can't work at both simultaneously. So in the x direction, we have to do ax equals f net x over m. So you can't. So f net isn't all the forces. It's all the forces in the x direction. We really aren't supposed to mix x and y. It doesn't really come up too often in this class. But we can't mix x and y. So we can only look at the horizontal forces. Okay, so a few things. First off, ax, the acceleration in the x direction is 0. The net force in the x direction, well, let's see. Let's plug in those forces. We have 130 minus force of friction, kinetic. Over the mass, we don't know the mass, but it doesn't matter because you cross multiply and you get 0 equals 130 newtons minus force of friction, kinetic. So the force of kinetic friction equals 130 newtons. Now, if I were to tell you that the answer to this one was 130 newtons, you'd kind of maybe see why. You'd say, okay, well, there's 130 newtons pulling it forward, and it's going at constant velocity, so there must be an equilibrium. So there must be 130 newtons pulling it back. Some people might say, why is it moving at all if the forces are equal? Well, remember, the net force in the x direction is 0. Net force only creates a change in velocity. If the object's already moving, as long as the forces are equal, it will keep moving at that constant velocity. Right? Yeah, you need a net force to start moving it, but once it's moving at constant velocity, as long as the force is balanced, it's going to keep going at constant velocity. Now, a lot of people don't answer this one by showing this work I showed here. They just say it's an equilibrium, so the forces need to cancel out. If I have 130 newtons pulling it forward, I have to have 130 pulling back. That's another way to do it. And for the last one, finding the normal force, we are going to use the equation force of friction kinetic equals mu k times the normal force. So the force of friction kinetic is 130 newtons equals 0.3 times the normal force, and we get 433 newtons equals the normal force. By the way, a lot of people for number 11 would try to use, let me just make a side note, they would try to use this equation to solve 11. The reason you can't use it is because as of that point, you know the coefficient, but you don't know the normal force. So you would not be able, and you can't find it. So you would not be able to use this equation for number 11, right? This is a tough question. Again, I've said before, probably the hardest Regents question that we would come across, right? So make sure you're able to do this one. Go through this a couple times on your own. If you need help with it, let me know, and have a great day, everybody.